Hello, excuse me, and welcome to screencast number 2 for chapter 23, the final chapter. And we're talking about minerals and mining. So we were looking at how we process metals after mining the ore. And processing minerals really is going to exert a lot of environmental impacts. Most methods that we are going to talk about are water intensive and energy intensive. Uh, when we extract the metals from ore, we emit air pollution. Smelting plants, in particular, have long been hotspots of toxic air pollution. And soil and water commonly become polluted by a substance that we call tailings. And these are little ore scraps that are left over after metals have been extracted. I can't stop this from happening. um, so they then pollute the water and the soil. Tailings may even leach heavy metals present in the ore or waste, as well as chemicals that have been applied in the process of extraction. And the contents that we use, or the chemicals that we use, are what you see listed here, like cyanide and sulfuric acid. We use cyanide to extract gold, and then we use sulfuric acid to extract copper. So mining operations, they'll often pump this toxic slurry of tailings into a very large man-made reservoir that they call surface impoundments. Now, an impoundment walls are designed to actually prevent leaks and collapse, but accidents can happen. There can be, as it says, breaches of surface impoundments that can have massive environmental impacts. There was one in Inez, Kentucky that released over 300 million gallons of coal slurry, and it went into the streams. It blackened about 75 miles of these streams, and it killed aquatic wildlife, and that affected the drinking water supplies for many communities. There have been breaches on the smaller scale where there's been leaching of toxic materials that occurs, and it's often difficult to properly line and maintain these large impoundments. So take a look. Here is what an impoundment looks like. And this is next to an area that is being mined, and you can see all of the mining that's happening here. Surface impoundment that you're seeing at Upper Big Branch Mine, and this is located in West Virginia. And it does hold the coal tailings from the surface mining operation, as I was pointing out to you, that is in the background. We also mine for non-metallic minerals, and these non-metallic minerals, non-metallic, they don't contain metal, so they're going to be sand and gravel and phosphates and limestones and gemstones. And these are substances that we use in building and roads, fertilizers, and of course as gemstones in jewelry. The most sand and gravel are one of the ones that are most commonly mined minerals, and they are used for fill and construction materials for manufacturing products. This is a $7 billion per year of sand and gravel are mined in the United States. $7 billion, I forgot to add the dollars, and used for fill and construction materials. The phosphates that we've already talked about are going to provide fertilizers. And then there's something called blood diamonds, and blood diamonds are gemstones that are treasured for their rarity. They can be regular diamonds, which we know the value of those. Like the coltan, diamonds have fueled many wars. The diamond trade has acted to fund and prolong all the problems that are going on in Angola and Sierra Leone and Liberia. Um, this is why you hear the phrase blood diamonds that go on. We also mine limestone and salt and potash and other minerals for other diverse processes that go on. The more we developed nations consume, the more economic demand that it puts on people elsewhere in the world. And people in developing regions like Africa and Asia to the Amazon are suffering unintended consequences of the developed world's appetite for these minerals. We also mine for substances that we use for fuel, like uranium, which we would use in nuclear power. Um, we would also mine for coal, as we talked about that before, and petroleum and natural gas. We talked about the oil sands and the oil shale, the methane hydrates. All of these are organic, but they are also extracted from the earth in some way or some form. Let's take a look at this map. This is the minerals we use that come from all around the world. It's shown as a selection of the economically important minerals and metals and nonmetals, and together with their major uses and their main nation of origin, only a minority of mineral uses and origins are shown. So we're just getting a fraction of this. So as I said, this map is going to show the minerals that we use that come from all over the world, and it just highlights a few of the minerals. It does not show all of them. But in Canada, one of the minerals that we mine is indium, and we use this for LCDs and for solar cells. Poland is big in silver, and we use that silver in jewelry and in currency. It was more widely used years ago in photography. It still is, but we use other things now in photography uh, and then electronics. The Ukraine, Russia, and Australia, they are big in iron, and this is in steel making and metallurgy and auto parts and paints and dyes. In Kazakhstan, chromium, and this is big in the chemical industry and for metalworking. Titanium in China. This is used in airplanes, aerospace, missiles, and in reconstructive surgeries. Tin comes in China, and this is steel plating for cans and alloys and solder and superconductors. Uh, China also is big for lead that we use in batteries. Again, solder. When you solder, that means that you are taking metals and you're binding other metals together. X-ray shields and TV tubes, and was also in paints and gasoline additives when we removed them. Uranium comes from Australia. We know that we use this in nuclear power and in medicine. Tantalum, and that's in Australia. And this is electric circuitry and auto parts and steel making and alloys. Again, in China, we're going to get tungsten for metalworking and machinery and light bulbs. Platinum from South Africa, and this is what we put in catalytic converters in the chemical industry and capacitors. South America is where a lot of our gold comes from, and this is for jewelry and monetary value, and coins and dentistry and medicine. Cobalt in the Dominican Republic of Congo. Alloys for jet engines and carbides for tools in the chemical industry. Aluminum comes from Guinea, and that's used in packaging and building and transportation. Phosphates from Morocco and Western Sahara, and fertilizer, industrial home chemicals. Zinc is big in the United States and also in China, and this is going to be coatings and alloys and auto parts and batteries and paints. Cuba and Australia gives us nickel, and copper is found in Chile. So those are some of the main ones around the world. Not all of them, but the primary ones. So when we look at the positive impacts of mining, and we're going to look at both the positive and the negative impacts. Mining for minerals is an important part of industry, and it provides job for people. It brings in revenue for communities in many regions, not just in a limited area, but for large regions. The mining supplies us with our raw materials, and we know that we use those for an unlimited number of products. Uh, it's necessary that we have those products for our lives. In 2012, the raw materials for mining contributed to about $76 billion to the U.S. economy. And then after processing, those mineral materials contribute about $704 billion. As far as employment is concerned, it employs over 175,000 Americans. And there's mining industry together with the processors and manufacturers and the products from the mined materials employ over 1.2 million people. So that's even beyond just the mining industry. But as you can imagine, mining also exerts a price on the environment, and it also has some social impacts as well. So, when we take a look, minerals of interest, really, when we find them in these deposits, only make up a small portion of a rock in a given area. But typically, you have to remove large amounts of material in order to obtain just that small amount of desired minerals. So mining disturbs large areas of land, and it exerts severe impacts on the environment and the people that live nearby. Also, depending on the nature of the mineral deposit, there could be multiple methods that could be employed to extract the resource from the ground. And the one that is chosen is going to be the one that is based largely on its economic efficiency, the one that is going to cost the less. So economy determines which method is going to be used. There are 7 major mining practices that are commonly used throughout the world, and we are going to discuss those 7 different mining practices, and we're going to point out the impacts of each approach, and of course we know the benefits of what we're getting from that. All right, we're going to start with strip mining, but I'm going to start with strip mining on the next screencast since we're about 14 minutes into this one.